In the next page, 20 through 23, I think it goes to. So let's hit number 20. Number 20 gives us a data table here. We got data value. So data value 6, frequency 3. So this 6 occurs 3 times. 7 occurs 3 times. So all it's telling us is that number and how many times it occurs in this big list of data. Okay. The frequency table summarizes the 57 data values in a data set. What's the maximum data value in the data set? So here's our data values. Maximum just means what's the largest. And so they put them in order. So the largest one is 14. That's it. And truth be told, everybody, I had to actually look up that answer for that problem because I didn't think it was that simple, but that is what they want you to do. Okay, to understand that if you're looking for the data value, you want this. They didn't ask you how much it was worth or like take that times the number of times it occurs or anything like that. That was it. Question 21. A circle in the xy plane has a diameter with endpoints of 2, 4, and 2, 14. So what I like to do is draw a quick sketch of that, and we just label these points. So this is like 2, this is like 4. We have another one at 2, 14, and so that's important for me to understand that that's a vertical line right there. So that's a diameter. So that must have the center in it. Okay, remember diameters run through the center. And so if this is 4 and 14, my middle point, they have a difference of 10, don't they? So I want this right here at 9. That would be my center. So I'm 5 away from that, and I'm 5 away from the 4. So 9 is the center point. I now know the center of my circle is at 2 and 9. The equation of the circle is x minus 3x minus r is a positive constant. What is the value of r? Well, r is simply your radius. And by the way, I did all this work. I guess I should have read my question first. Because right here, you can see I'm shifted to the right by 2. So my center is over by 2. And my center is shifted up by 9. So I'm shifted up by 9. So there's my center. They want to know what the radius is. Okay, that's what R is. R stands for radius. So I just have to figure out, well, this distance I already marked right here. It's 5 units. So I say, hey, the radius of my circle is 5. I already had that kind of figured out right there as soon as I made those 5s. This is my diameter. That is my radius right there. And so we're done. We don't have any units on this thing, so we don't have to worry about that. This is open-ended, so we just go 5. R is 5. Let's see here, 22. The measure of angle R is, measure angle R equals 2 pi over 3. You don't have to understand what radians are right now. Think of it as like it's kind of like measuring in degrees, but a different unit. The measure of angle T, I guess I should have angle R and angle T like this, is equal to 5 pi over 12. Radians greater than R, more than R. What's the measure of angle T? Okay, so 5 pi more than R, so I just got to add those two together. So here's angle R, 2 pi over 3, and angle T is 5 pi more than that. So I just add those two together. And let's see, I have to get a common denominator here. So I'll do that in blue ink so you can see it. I want a denominator of 4, or 12 rather. So I'm going to multiply this first fraction by 4 over 4. And that gives me, I'll change it to purple so you can see it transformed. It's 8, it's not very purple, 8 pi over 12 is what that turns into then. And that's nice because now it has the same denominator as this 5 pi over 12, and I can add those together and get 13 pi over 12. There we go, that's how big angle T is. Oh crud, what's its measure in degrees? Darn it, so we gotta do one more conversion here, but this is relatively simple. And you have this on your actual formula sheet for the SAT test, it says 2 pi is equal to, I think, 360 degrees. It tells you this. And so this really gives us a conversion factor that there's 360 degrees per every 2 pi. And that's what we do right here. We just have to take this times 360 per 2 pi. So go times 360 per every 2 pi, and I'll just have units of degrees. So the pi's would cancel here. 12 goes into 360 20 times. 20 can be divided by this 2 to give me 10, leaving me in my denominator nothing. Everybody's canceled with someone in the numerator except for the 13 and this 10. And 13 times 10 is 130. So apparently I've done something wrong. 12, oh, there it is. 12 does not go into 36 20 times. It goes into 36 30 times. And now the 2 no longer cancels the 20 and gives you a 10. It cancels the 30 and gives you a 15. So I've got on my numerator, I have a 13 times a 15. So darn it, that's not as easy. So 13 times 15. Let's set it up like a long multiplication. 15 carry 1, 5, 6, 3, 1, 5, 9, 195. There we go. Kind of a rough one with lots of scribbles. I guess I should have run to my calculator right there. Okay. And truth be told, you can probably do this on your calculator. I'll type it in real quick. So if it makes sense that you need to add the 5 pi and 2 pi over 3 together, calculator here real quick. And so I'll just start with this red line, 2 pi over 3. So I'll go 2. I'll type in pi by just going 2 pi like this. And then I go over 3. So there's 2 pi divided by 3. And then I want to add on 5 pi over 12. So 5, 5. I see I got a little mistake here. So 5 pi. See if I can get back here and correct that. Make that into a plus sign. And then over 12 like that. There we go. So I've added them together. And the problem is I do get this 13 pi over 12. But see, I can't see that in here. Okay. So it's taken my red answer here and it's turned it into a decimal because it's using 3.14 for pi. However, if I am very, very careful here, I should be able to now take this answer that I have, multiply it by 360 over 2 pi, and it should give me that 195. But I'd have to be super careful. I'd have to throw in the two things I added at the very beginning. I'd have to throw those in parentheses, like this, and then over here. So that would have calculated at this point the summation that I had to calculate, these two red things. Then what I want to do is take that answer, which is now in parentheses, and take it times 360 over 2 pi. So I'm right there, and I go times, and I'll put 360 divided by, and I'll put 2 pi down there. And so now it's doing all that math for us. And even though the pi is getting converted to decimals, those decimals end up canceling out. You do get that 195 just like we did. All right, last problem, 23 here. A certain town has an area of 436 square miles. So here's my town, 4.36 miles squared. What's the area in square yards? Okay. So this is a unit conversion. So let's start with 5.36 square miles. So we write it like this, miles with a 2 on it. And they give us a nice conversion factor that says there is 1 mile per this many yards, 1,760 yards. So we'll just take this times it, Okay, if you've done this in chemistry, maybe you go times, and you put your conversion factor here. Now, I need yards in the numerator and miles in the denominator. So I write it as 1,760 yards on top over 1 mile in the bottom. And I want it this way, and I know to set it up this way. The 1,760 has to be at the yard, so I can either put the 1,760 yards on top or on the bottom. I want them on the top so that the miles are on the bottom to cancel these miles that are in the numerator. This is like this 4,136 over just a 1 here. The denominator has no units. It's just kind of a 1, so you can see this is in the numerator. Okay, so miles are going to cancel miles, and the yards will be your answer. However, this only cancels one of the miles. This is miles times miles, and we only have 1 here. So what we're going to have to do is take it times another, okay, 1,760 yards per mile. So this is just a version of 1 right here. Okay, but the units then make it change the way this looks. Changes its value by changing it into a different unit of measurement. Now, so this is how you could calculate this, and now you can see miles will cancel 1 mile, and the mile will cancel the other mile, leaving you with yards times yards, or yards squareds. But in practice, we usually don't write it this way. What we do is just say, hey, I've got to do this twice, like this. And then we don't have to write it 2 times, but it means exactly the same thing. But now when I calculate this on my calculator here, I'm going to go 4.36, because that's my numerator, 36 times, and in this case, I just have to do the 1,760 squared, like so. And that's how many square yards it is. That's huge. That is, oops, 1350553 6. I'm going to get my commas in there to help me figure out which number it is. Yeah, there it is. That is D, if you can tell.